when the team began their lunar lunacy jigsaw puzzle.
Say hoax.
Hoax! They knew they couldn't cover every conspiracy cheerleaders claim.
This is the moment of truth.
But the few pieces they have put in place
That means it's busted.
Totally busted.
tell the same story.
In your face, conspiracy theorists.
With the fat lady waiting impatiently in the wings, there's time for just one final test. And not just any old test, but the ultimate proof of man's moon mission.
What's this?
A reflector.
In fact, it's called a retroreflector, made up of many tiny prisms just like this. And did you further know that the Apollo astronauts were nice enough when they visited the moon to leave several of these on the surface so that Earth-bound scientists could point lasers at it and gather information about the moon?
So what you're saying is that we get a really big laser and point it at the reflector on the moon, and if we get a signal back, that means that we were in fact there.
Precisely. Okay, it breaks down like this. A retroreflector bounces light back at the light source, regardless of the angle. This differs from a mirror where the angle of incidence has to be perpendicular. So, if there was a retroreflector on the moon, and we knew its exact location, and we had a powerful enough laser,
Say hoax.
we could detect the reflection and prove there is man-made equipment on the moon.
What are we supposed to be doing?
Technically, we're supposed to have a conversation about where we are.
Oh, you mean like the Apache Point Observatory? This thing right here is the Apache Point Observatory. What a view. And these guys have the tools that we need to put the final nail in the coffin on the moon landing hoax.
Yep, up here in the Sacramento Mountains, New Mexico. Adam and Jamie meet one of the observatory's top docs, Russet McMillan.
How can I help you today?
Well, it seems that there are some people that do not believe that man has actually been to the moon.
I've met some of them.
What do you think?
I think they're crazy.
A bold statement, but Dr. McMillan has the hardware to back it up.
Here's the thing. This little laser pointer is about 10 milliwatts. That's great, but it's not going to make it to the moon and back. That thing, however, peaks at 1 gigawatt. That's 100 billion times more powerful than this is. That's what you got to have to make it to the moon and back.
This is actually not a bad imitation of exactly what's on the moon that we're shining the laser into. In fact, the specific one we're shining into was left there by the Apollo 15 crew. Now, we're firing on the order of 200 quadrillion photons per laser pulse at that reflector, and we're getting between 1 and 3 photons back per pulse if we're lucky. When we get that photon back, we'll see a spike like that on the screen.
I am slewing the telescope to the lunar highlands.
Slew away.
Test number 1, shining our laser at a portion of the moon's surface devoid of all man-made objects, including retroreflectors, known to locals as the lunar highlands.
There's the moon. You can see the craters.
With the laser pointed at a random location on the moon's surface,
Initiating laser.
Dr. McMillan pulses 200 quadrillion photons into the night sky.
So we're shining the laser on the lunar highlands now, and we're getting nothing back except background light.
As expected, the lunar regolith, with its reflectivity index or albedo of approximately 8%, simply scatters the beam, and the sensors back here at the observatory detect no reflected light.
Now I'm going to move to Apollo 15.
Woohoo!
Apollo 15, crewed by Scott, Irwin, and Warden, set down at the base of the lunar Apennine Mountains, which is where they placed the retroreflector.
Wow.
That's the location where Apollo 15 landed on the moon.
That is so cool.
Initiating laser on retroreflector from Apollo 15. And there's a spike beginning to stand out.
Is that it?
That's the return from Apollo 15. Light returning from the laser retroreflector at exactly the wavelength and distance that we were expecting.
That is so cool. I know you do this like 100 times a year, but it's really thrilling to watch it happen right in front of us.
Not just thrilling, but conclusive.
Look, I'd love to go to the moon, but I can't. At least not right now. So we did the next best thing.
We shined that laser at the moon on the second test, and we got a clear spike back. Photons came back to our receptor. Now, the only way that could happen is if there was a piece of man-made equipment up on the moon to reflect them back.
So get over it. There's no conspiracy here.
We've been there. We've done that.
So the team have busted everything before them
What's that, Neil? We really went to the moon.
and compounded those 5 results with evidence of lunar-bound man-made equipment. This moon mystery jigsaw puzzle is complete.